Hi and welcome to this session. In the next half an hour, we are going to cover a quite interesting topic regarding the strategy and best practices to successfully implement IoT projects. The reason I'm here today talking about this topic is that too often IoT projects are not delivering on the expectations set by the stakeholders. A market survey conducted by Belgium Research uncovered that only 12% of the companies that have been surveyed consider their projects as successfully implemented. And as many as 70% mentioned security and scalability as their major technical concerns, preventing them from successfully carrying out the project. In this session, I would like to guide you through the journey of those companies that are successfully implementing IoT projects, highlighting how to avoid some of the most common pitfalls encountered along the way. We're going to look into which are the challenges the customer face when embarking on IoT projects, and then we will analyze the three main phases of a project more in detail: the ideation phase, the prototyping phase, and the production. We will conclude the session with some takeaways summarizing what we learned. My name is Massimiliano Angelino, and I am a Principal Specialist Solution Architect in IoT, and I work with customers of all sizes in multiple verticals across Europe. I am based out of Stockholm, and it's a pleasure to be here today to talk about this subject so that you can be better prepared when starting your next IoT project. We talked about challenges, and we named two of them already: security and scalability. But there are more. In the same survey conducted by Belgium Research, the respondents listed several reasons for their projects not achieving their expected results. On the technical side, customers mentioned constrained analytical capabilities, security, incomplete requirements, and lack of skills. On the business side, unclear business cases and lack of strategy were some of the top reasons for which the project outcome was not successful. Another issue I tend to see is about the way that customers approach IoT projects. In too many cases, they adopt the traditional IT agenda, which has slow and long cycles, year-long budgeting processes, and a resource-driven approach. IoT projects, on the other hand, require faster development cycles in order to adapt to the rapidly changing requirements which are driven by customer needs, and are best addressed by focusing on the outcomes of the project than the resources allocated for its execution. IoT projects might not be direct revenue generators in the short term, but they typically enable new groundbreaking business models or process improvements that can have long-term benefits for the whole company. Therefore, benchmarking these projects on resources might lead your company to go amiss great opportunities to innovate. Another difference between the traditional IT projects and IoT projects is that the former are typically complicated, while the latter are complex. What do I mean by that? Take the manufacturer of a mechanical watch. It is complicated, but given enough time, focus, and skill, it can be done. The solution to complicated projects is known, and it has already been done before. It just takes time and resources to get there. In IoT projects, on the other hand, the outcome itself might change over time, as the needs of the customer evolve as well as the surrounding context changes. Meaning that teams will have to continuously reframe what to deliver and how to deliver it. A good analogy of complexity are the ever-changing patterns of two-fluid mixing. Now let's start with the ideation phase. We mentioned before that IoT solutions can be complex because they typically involve multiple layers in an organization, encompassing technology and business. The complexity comes from the combination of the technology covering multiple domains, from hardware to machine learning, and from the tight coupling with the business expertise. Few customers are able to put together teams with this know-how. Another pitfall is that too often I see customers over-engineering their solution from the start, when it is still on the drawing board, quickly losing the sight of what the project set out to solve, by trying to generalize the solution in order to address yet unknown use cases. Finally, the result is typically uncertain because the requirements, even when clearly defined, tend to change faster than the typical project time, resulting in projects that once delivered are not providing the desired outcomes. Is there a way to address these issues and ensure that what you're set out to implement and build is actually going to provide you the expected results? I like to use this quote from Jeff Bezos: "We innovate by starting with the customer and working backwards." to introduce a methodology called the working backwards process. I will not go into too much detail, but I want to introduce you one of the core mechanisms, the press release. The press release is a one-page narrative explaining the project vision using customer-centric language. One goal of the press release is to leap into the future and imagine how we want customers to feel and what we want them to say when they experience the product, the feature, or the service that we want to create. Writing a press release clarifies how customers will see the idea, not just how we think and speak about it internally. It is also a fantastic tool to help drive the right conversation with the development teams and stakeholders. To facilitate the thought process needed to write a press release, it is useful to start by asking yourself a few questions to better understand what you are setting out to build. Who is the customer? What is the customer problem opportunity? What is the most important customer benefit? How do you know what the customer wants or needs? What the customer experience looks like? Each answer provides food for thoughts for you and your team and helps you in understanding if what you're trying to build is useful for the customer. Moreover, it provides also data for future feature prioritization. It also helps in assessing if your initial idea generates the necessary outcomes and allows you to quickly iterate an alternative solution, which is definitely less costly at this stage than once the prototype is completed. If you want to read more about the working backward process, you can add to the link at the bottom of the page. Let's assume you have a really clear idea of what you want to achieve. You have agreed with your stakeholders thanks to the fantastic press release you just wrote, and are ready to start a prototype to iron out the technical solution that will allow you to achieve your vision. In this phase, if this phase is not approached in the right way, you'll be facing a dire reality. Up to 30% of the IoT projects are in some way or another not going further than the prototyping stage. The main reasons behind this figure are the lack of skills, failure to show results in time or budget, and spending too much time and effort and resources in reinventing the wheel, with teams focusing on building infrastructure instead of business solutions. Let's start from the lack of skills. IoT solutions cover multiple technical domains, from device hardware and firmware, communication networks, backends and data ingestion, scale, and data processing, machine learning, and user application, to name a few. Having teams with an holistic know-how of all these technologies is hard, and especially uncommon for all those customers for which IoT is not the core of their business. There are a few ways your company can address this issue, starting with training your workforce, taking advantage of the multitude of online courses and resources available. This is definitely the best investment strategy for the future, but in reality you are typically working under tight project deadlines. And this brings me to another quote from Andy Jassy: "There is no compression algorithm for experience." In this specific context, address prototyping and partners can help you by providing that experience for day one. I'll explore how AWS prototyping can help you in a moment. I also see many customers spending too much time on building infrastructure services, being these an MQTT broker, an analytics platform, or data processing pipeline, instead of focusing on delivering the results and building a functional solution. This is exemplified by the current trend of using Kubernetes to run all sorts of workloads, the main justification being portability, using best-of-breed software, and known tools. These teams spend too much time in configuring and running these infrastructure services, instead of using functionality equivalent managed services with few API calls. As an example, I've been challenged by customers that have stated that they could not use IoT Core Broker as it lacks support for some specific MQTT version 5 feature. It turns out that while that feature is useful when building a solution on premises, AWS provides services such as Simple Queue Service, SQS, and Simple Notification Service, SNS, that can be used to solve the same problem. On the other hand, the gain in the managed services is that not only their scalability, reliability, and security, that all characteristics that will play a major role when going into production. This leads me to the third cause of unsuccessful prototypes. Too many times the teams will set themselves too ambitious targets, which combine with the reinvent the wheel approach often leads to the inability to show any results in a reasonable amount of time, which is cause of frustration both in the team and in the stakeholders. My recommendation here is to divide and conquer, targeting first the low-hanging fruits, those easier to achieve tasks that allow you to quickly show results with little effort, and then at the same time help in validating the course of your project is taking. Then iterate, using a time box approach, in order to continue delivering at regular cadence, and at the same time continuously validating your approach. Which leads me to another quote from Jeff Bezos. If you're good at course correcting, being wrong may be less costly than you think, whereas being slow is going to be expensive for sure. AWS Prototyping is an awesome resource that can help you in achieving the goal that you set for your prototype, bringing their extensive expertise gained through hundreds of projects. Their approach is to work with the customers in short-term engagements of maximum 8 weeks, during which they co-build the project, evaluate alternative solutions, and train your team on the service being used. Here are 2 customers where the prototyping team had a huge impact in their ability to quickly get to a stage where they were ready to go to production. The first customer is ProGlove, a German manufacturer of handheld scanners that had the idea of introducing a smart glove which would help reducing worker fatigue and provide immediate feedback in case of wrong items were scanned. This meant connecting the gloves to the cloud. The prototyping team provided the necessary insights to bring the project implementation on the right path from the beginning and saving the customer 12 weeks of development time. The Mark Glove is helping customers to be more efficient and gain insight into their processes at a whole new level. The other customer is Scania, a Swedish truck manufacturer. They wanted to optimize the data collection and diagnostic processes for truck being serviced. Their current processes were mostly manual, lengthy, and error-prone. In this project, in which I was also involved, AWS Prototyping worked with the customer to implement in as little as 2 weeks a solution based on AWS Greengrass, running on their existing workshop Windows workstations, with the result that delighted their final users. But if you have the necessary skill and set out on building the prototype with your own resources, you can still get a lot of help in reducing the effort your teams have to put into building the solutions. IoT projects involve almost always some sort of hardware device. Nowadays, the go-to hardware platform to start prototyping is the well-known Raspberry Pi. This is a fantastic platform for experimentation, which is supported by the most AWS services, but it might not be suitable for your production needs. Industrial application, for example, could need ruggedized enclosures which are dust and humidity resistant, better quality cameras, or so on. The device catalog provides you a large selection of devices that have been qualified to work with AWS IoT services and provide both getting started guides and support from the vendors. If you need help in defining the architecture for your solution, the AWS Solution Catalog provides hundreds of artifacts, from constructs designed according to our best practices that you can pick and choose to integrate in your architecture, and to end-to-end solutions that you can be used as is or as blueprints for your design, and also a solution for which you can engage with a partner or a professional services to help you customize and deploy. Let's look at what it looks like using the Solution Catalog. If I head over to the solution library by typing awsamazon.com IoT solution in my browser, I will be presented with this screen. I see here all the available solutions, and I can further narrow down the results by using one of the categories: industry services, use case, solution, and type. Let's select AWS solutions. These are solutions created and managed by AWS, possibly in collaboration with partners, as in the camera connector solution. Let's select the connected vehicle solution in order to see how this solution more in detail works. Here I can read more in detail what this solution provides and understand the whole architecture behind this solution, with all the services, and I can get additional information by checking the implementation guide or the source code. Finally, I can also deploy the solution in my own AWS account, thanks to the CloudFormation template, and start ingesting data from real vehicles or simulated entities. I can then dive deeper in the solution by accessing the additional resources that are presented on the page. Here are some other examples of what you can find in the solution catalog, such as the Greengrass-based machine learning at the edge implementation, that you can tailor to your specific needs to run machine learning at the edge. If you want to connect industrial assets, you could, for example, start by deploying the connected factory solution on your own, and later engage with AWS partner or professional services to build it further to fully meet your requirement. And these are just a few of the solutions available, and I encourage you to go to the website and browse through the catalog. Now, like ProGlove and Scania, you have now a working prototype and the support of your company leadership, as you have been able to demonstrate the value of your idea in a really short term. The next step is to make this available to the customers for which the solution was built for. Is your solution ready? Are your teams ready? Bringing a prototype into production has its own set of challenges, and your mileage can vary depending on the nature of your solution. For example, procuring devices is different if your product is for internal company usage or external customer. But in general, you will have to deal with some of the following aspects. First of all, unless you're just deploying some software agent or mobile app, your project will involve some device of sort. It is quite common to have done the prototype on devices such as the Raspberry Pis, as I mentioned earlier, which in some cases could still be a platform of choice even in production. But in projects addressing industrial environment or targeted at external usage, you will have typically to manufacture and procure the devices specifically for your use case. Another challenge is connectivity. Are you going to use existing connectivity in the location where these devices are deployed? Are you going to use cellular connectivity? Do you have a low-power device and are considering narrowband IoT, LoRa, or Sigfox? The selection of the connectivity solution has likely been sorted out during the prototype, and now is actually a matter of finding the right partner that provides you both coverage, automation, and tooling to integrate into your solution. During the prototype, you worked on a handful of devices, but in production, you need to have a secure and stable process in place to manage the life cycle of thousands of devices from the initial onboarding and commissioning, monitoring their functionality over time, performing over-the-air updates to correct bugs and add new features, troubleshooting, and so on. And these require a different set of tools that are both scalable and secure. And security should have been already addressed from the start. At Amazon, we say security is job zero, and you should do the same. As I mentioned in the beginning of this talk, security is one of the main concerns customers raise, but there are plenty of tools and best practices to develop secure systems, from authentication authorization of your devices using certificates, encryption of data in transit at rest, and ongoing monitoring of security threats and incidents. Last but not least, your devices might need to be deployed over the globe. And you need to think about how your backend can ensure that latency requirements are met, or that you have the right disaster recovery strategy. Does it seem like a daunting task? Sure, it could be if the solution has been built on the wrong foundations and not following the best practices covering each of these domains. But to help customers in confidently bringing their solution to production, AWS provides the Well-Architected Tool. This is a free tool that allows you to review your current and future workloads against the current best practices and provides guidance on how to improve your cloud and device architectures, ensuring that you have the necessary solid foundation to bring your solution into production. When you analyze your workload through each of these pillars, operational excellence, security, reliability, performance, efficiency, and cost optimization, you're going to gain insights about the possible shortcomings and possible improvements of your solution, giving you the necessary confidence in moving the prototype into a production system. We also have a specific IoT lens that applies these pillars to IoT workloads and provides guidance for things such as MQTT topic design, device security and onboarding, fleet monitoring, and so on. What else can AWS do for you in order to successfully achieve the business goals of your solution? At AWS, we say that nobody just buys IoT technology, they seek business outcomes. And to get to these outcomes, you need more than just IoT services and IoT technology. In AWS Cloud, you have access to more than 175 services, such as storage, analytics, machine learning, blockchain, helping you in building a solid, secure, and scalable foundation. Professional services can help you as they have helped thousands of customers, bring you the necessary expertise to ensure the success of your projects. And finally, you can rely on an extensive ecosystem of technology and consulting partners that can provide you end-to-end solution in specific vertical industries, or additional building blocks such as devices and connectivity services. The foundation of your solution can be built reliably and securely on top of the AWS IoT services. From the devices, with Greengrass, FreeRTOS, and the SDKs, to the connectivity and control services, with the AWS IoT Core Device Management and Device Defender, that provides a continuous monitoring of your fleet security posture. AWS IoT also has fully managed services for data processing and analytics, such as Sitewise, IoT Analytics, and IoT Events. All these services integrate seamlessly with the remaining AWS services, both from a functional point of view and in terms of security and governance. As an example of this tight integration is exemplified by AWS IoT Greengrass platform, which is a software stack that you can run on your device and integrate directly with machine learning. For example, you can collect data at the edge, push it to the cloud to train machine learning algorithms with SageMaker, optimize the resulting model with SageMaker Neo, and deploy it back to the device, where you can run local inference, reducing latency and data transfer cost. Professional services can help you in filling the skill gap and help you deliver production solution. Let's look at two customers that professional services has helped. For EcoFit, a company that manufactures and sells fitness machines, professional services implemented a solution based on Greengrass to broker messages exchanged locally by several pieces of equipment, process and filter this data, and only send aggregated insights to the cloud. With this solution, EcoFit was able to provide equipment owners more accurate information on the usage and the health of the machines to optimize their purchase decisions. In the case of Toyota Connected, which is a digital branch of one of the largest car manufacturers, professional services implemented a solution on top of the AWS IoT to connect aftermarket vehicle devices to their Toyota Connected platform in order to provide unique services such as driver and trip analysis to their customers. Professional services works with proven methodologies based on industry best practices and can bootstrap your project using battle-tested solutions in several domains. For example, if you are a white good manufacturer and are looking at a solution to connect your appliances, you could benefit from the connected product solution. If you are into manufacturing and want to improve your quality and decision processes by retrieving data in real time from the factory floor, the connected factory solution provides a necessary foundation and can be tailored to your specific need. Moreover, they can also help you in the initial phases of your project with a discovery workshop to apply the working backward process. AWS has an extensive end-to-end device-to-solution partner ecosystem, from which you can source devices, find a connectivity solution or partner, engage with a qualified consultancy partner, or procure end-to-end solutions specific to your use case. With this, we have come to an end of this talk. We started this session by assessing that many IoT projects are not successful, and we listed some of the reasons why this happens: lack of skills, unclear objectives, incomplete requirements, uncertain path to production. We then looked into each of these phases a project goes through and provided some best practices on how to approach IoT projects in each of the phases to ensure a successful outcome. To summarize, for a successful strategy, I would like you to remember the following three things. Never lose sight of the business outcomes you set for your project at every single step of your journey. Ensure to have a quick turnaround and use a time box approach during the prototyping phase in order to ensure that you are delivering the expected result while retaining the ability to course correct without incurring too much high cost. And finally, build your solution on solid foundation, ensuring that you have the security, performance, and scalability needed to bring your idea to production. To dive deeper on what AWS has to offer and how we can help you in successfully implementing your projects, you can head over to the following resources. And finally, if you are interested in reading how AWS is helping customers in implementing successfully their IoT projects, head over to the AWS IoT portal to read about Volkswagen, iRobot, Bayer, or Woodside. Personally, I really like Woodside Journey, and I recommend you to watch their presentation from Remars 2019. Thank you for listening, and I hope that you will have the chance to interact with you all as you're applying these advices to successfully deliver your groundbreaking IoT projects.